Viewers, welcome again to All Force e-learning program, a new episode of All Force e-learning program. It's me again teaching physics for you. In the previous class we were talking about the process of electrification. Today we will continue with the next method of electrification process. Before that, let us have a preview of what we have learned in the earlier class. So I was telling you, first, charge. Charge is the intrinsic property of a fundamental particles like electrons and protons, which accompany them wherever they exist, and they, by virtue of which they exhibit the property, they exhibit the effects of electric and magnetic effects. Charge. The process of giving charge to a body is termed as electrification, right? So I was even telling you the various basic properties of charge. Charge exhibits, charge has some fundamental properties it obeys, like charge is a scalar, charge is additive, charge is transferable, charge is always associated with mass, charge is conserved, charge is quantized, and charge is invariant. Now, these are the basic properties of charge. Next, how do you give charge to your body? The process of giving charge, electrification. There are 7 methods of electrification process. We have dealt with 2 yesterday. First one, charging by friction. Consider 2 bodies, one of which must be an insulator, put them in contact, move relatively, then electrons are transferred from one body to another body. The body losing electrons attains positive charge, the other one negative charge. This is charging by friction. In charging by friction, always 2 equal and opposite charges are produced, and in any process charge will be conserved, because we started with 2 neutral bodies, no charge, net charge is 0. Even after getting charged, positive plus q, another minus q, net charge is again 0, right? So after being charged by friction, these 2 attain 2 unlike charges, positive negative. Now later they will attract. So in charging by friction, after being charged by friction, the bodies attract one another. This is the first process. We have even taken the formula, charge obtained Q plus Ne. One of the body will get plus Ne, other one is minus Ne. The second method is charging by conduction. Now for this, you should already possess a charged body, and you will share this charge to other bodies. But you can share this only to a conductor, right? Sharing the charge to a conductor by contact, either by direct or indirect contact. So sharing the charge to different number of things, right? This process is called conduction. Here also charging takes place by transfer of electrons. Now the third method is charging by induction. Charging by induction. Now, in charging by conduction process, what we were doing is we were possessing a charged body, already possessing charge, and we were sharing this charge to other bodies. Now, while sharing, the first body loses some of its charge to other one. So, as it shares to many bodies, its charge decreases, its charge reduces. Now, you get a doubt. Is it possible to charge a body without losing its own charge? Without losing its own charge, can you charge another body? Now you get a doubt. How is it possible? How can you charge another body without losing a charge? Because charge is conserved. So I have been keep telling you that charge is always conserved. Charge can neither be created nor destroyed. So how can you produce charge in another body without losing charge? But you know, to your amazement, it is possible. The method is charging by induction. That is the reason this is the most preferable method of giving charge to a body. Because in this one, the charged body, what we initially consider, without losing its own charge, it produces charge to the other body. Now you get a doubt, how is it possible? Now I was telling you yesterday, in the previous episode, electrification takes place by transfer of charge or by redistribution of electrons. Transfer of electrons or redistribution of electrons. The second, redistribution of electrons takes place in this. Now how does it take place? Please look. And one more thing. In charging by friction, you can produce charge even on an insulator. In charging by conduction, you can produce charge only on a conductor. You cannot produce charge, you cannot transfer charge share to an insulator, because insulator does not possess any free electrons, it doesn't obtain charge. But in this one, you can give charge to an insulator as well as to a conductor, irrespective of the nature of the body electrically. You can give charge to anything. Now how? Consider a charged body, right? This is a charged body. This already possesses some positive charge. This is already possessing some positive charge. Let's say some Q naught. Now you want to produce charge on another body. Now get that body very close to it. Don't put in contact, just put it very close to it. Now when you put it very close to it, because of the influence of this positive charge on this, now this is actually neutral, it possesses equal positive and negative. Then because of the influence of this positive charge, the electrons in this body, the free electrons in this body get accumulated on the nearer side. The electrons get accumulated on the nearer side. So there is more abundance of negative charge on one side, and there is deficiency of negative charge on the other side, positive. Or most of the negative charge gets accumulated on one side, and there is deficiency of negative charge on the other side. So electrons move to one side, and the other side positive charge is accumulated there. Now this is again electrically neutral. Later, what you do is connect the positive side of the body to the earth. This is the electrical symbol for earthing. You know, earth is a huge conductor with abundance of charge. It can give you any amount of charge to you, or it can take any amount of charge within itself to itself. So this is the symbol for it. So when I connect the positive side of this one into the earth, then the electrons move from the earth to the body. So transfer of electrons take place from earth to this body, and they neutralize this positive charge. Electrons move from the earth to the body and neutralize the positive charge. Now only negative remains on this, but still it is not fully charged because it is associated. Now, so there is negative charge that is contained in it. Now slowly remove the earthing and isolate this. Remove the earthing and isolating the positive charge. Then this body will have this negative charge uniformly distributed in it. Now look, this body, without losing its charge, we have produced negative charge in this. By this method, you can produce charge, you can give charge to any number of bodies. So using one single charge, you can produce any amount of charge. That is the reason why it is the most preferable method of charge. I was telling you this is the most preferable method, because using a single charge, you can produce any amount of charge to other bodies. But opposite, unlike charge. In charging by friction, two equal and opposite charges are produced. In charging by conduction, whatever charge initially you consider, same type of charge is given to the body, same nature of charge is given to the other body. But in charging by induction, opposite charge, unlike charge, is being induced at the body in this process. But this way you can produce any amount of charge. Any amount of charge can be given to this body, right? You can produce any amount of charge with a single charge without losing its own charge. But again, charge is again conserved. This charge remains. This was actually electrically neutral. Some electrons move from the earth into this one, right? So as a whole, with this total isolated system, the total system of this and the earth, the total charge is conserved, right? So this is the method. I shall now show you the schematic diagram of the charging by induction. Now I shall show you the schematic diagram of the charging by induction. So this is the body on which we want to induce charge. Put over a stand like this. Now get a charged rod, positive, let's say positive, very close to it, when it is brought very close to it like this. Then due to the influence of this positive charge, the electrons, the free electrons in this one move to the nearer side of this body. So there is abundance of negative charge here, and the other side there is deficiency of electrons this way. So first, when I get a charged rod very near to the close to the body to which I want to produce charge. Now later, this first when I bring it, it comes to this position. Later, now the charged rod being placed very close with this. Now I shall connect the positive side of this body to the earth. I am connecting it to the earth like this. So we know charge always flows from high potential to low potential. So therefore, electrons move from the earth. Earth is a huge conductor with zero potential. This is positive. Electrons have high potential here, they have less potential here. So electrons move from the earth to this one, to this. They neutralize this positive charge. So now later what happens? This charged rod remains like this, positive. Now negative charge is contained in it, right? And now I remove this earthing. So when I remove the earthing, negative charge remains on it this way. Now remove the charged rod close to it. So finally this have negative charge that is contained like this. This is the schematic diagram of charging by induction, right? First, when you move a charge very close to it, electrons are attracted towards it. Like unlike charges, electrons are attracted and opposite charge will be accumulated on the other side. Now earthing the other side to the earth, all the electrons move from the earth to this, neutralize. Then the negative charge is contained in it. Now remove this. Now the charge is uniformly distributed. So this is the method of charging a body by induction. In induction process, unlike charge is being induced. Whatever charge that is induced on the body is called induced charge, and the process is induction. Induction is affecting something without any contact. Now based on this one, there was a beautiful question asked earlier in one of the entrance examination. A charged cylinder, right, is brought very close to a positive charge. A charged cylinder is brought very close to the positive charge like this. Then, so due to induction, there is negative charge here and positive. Now, what is the net charge on the cylinder? He has asked you, after being, when there is induction taking place, what is the net charge on the cylinder? The net charge on the cylinder is 0, right? Positive there, negative. After being earthed, so when you earth it, then the positive charge is lost, negative remains. Right? This was a question that is asked. And now in this process, I shall now give you a formula for the amount of charge that is being induced. How much charge will be induced on this one? The amount of charge that is induced on a body. Let's suppose this is an initial charge which I have considered with an initial charge Q naught. I want to induce charge on a body. This was the neutral body on which I want to induce charge. So how much negative charge is induced on this one? So what negative charge will be induced after being at, right, like this? What negative? The amount of charge that is induced, Qi. The induced charge Qi is given as minus Q naught bracket 1 minus 1 by K. Now this is the formula giving you the amount of induced charge that is being produced on the body. Q induced ion is minus Q naught of 1 minus 1 by K. Now there is the opposite charge is being induced. If this is positive, negative charge will be induced. If it is negative, positive charge will be induced. Q naught is the initial charge what we consider. Now what is K? K is actually called as the dielectric constant of this material. So I was telling you, in this process you can give charge to any body irrespective of its nature electrically, whether it is a conductor, insulator, whatever it is. So the electrical nature of the body is determined by a parameter called K. K is called dielectric constant. It's called dielectric constant. So based on the value of K, charge will be induced. Let's say, suppose if I consider this, if this is a conductor, if it is a conductor, the body on which I am producing charge, you know, for a conductor K is infinity. The dielectric constant is infinity. So putting infinity there, substituting this one. So charge induced on a conductor is minus Q naught bracket 1 minus 1 by infinity. We know 1 by infinity is 0. So this is 0. So therefore Q induced is minus Q naught. So any equal amount of charge is induced on the body but opposite in nature. This way you can induce this way any number of times, innumerous number of times. So that way minus Q, innumerous number of minus Q charge can be produced using this without losing this its own charge. So this is the method of charging by induction, right? Thank you. Hi viewers, welcome to another session of All4C learning program. Right, today we are going to learn about Coulomb's law, its properties, applications and limitations. Talking about Coulomb's law, before going to Coulomb's law, let's have a review of what we have learned yesterday, the previous video. Now I was telling you charge is a fundamental property of matter which is responsible for a special force called electric force. So earlier people observed a special force between matter which was stronger than the gravitational force. It was different from the gravitational force. The gravitational force between two masses is a feeble force, weak force. But people observed a strong interaction between two bodies. So for this special force there may be a special property and they termed it as charge. So electric force between two bodies, they named it as electrostatic clinch. Electrostatic clinch is the force of attraction which binds them together. Electrostatic clinch is due to the charge there. Unlike mass, you know, mass as stated by Sir Isaac Newton, gravitational force is of only one type, attraction. Gravitational clinch, it's of only one type, there is attraction. Mass, all matter is of only one type. But the electrostatic clinch or electric force, they have observed of two types. There are two types of forces. For example, let me tell you, let us have a small demonstration. Consider, we have studied electrification. The process of giving charge to a body is called electrification. I have explained various methods, right? Charging by friction, charging by conduction, charging by induction. And one more point to note is, charge always appears in pairs. You can never produce single charge. When you give charge to another body, let us say positive charge, this body giving, the body that is giving gets negative charge. Equal and opposite. Charge always appears in pairs. You can never produce a single charge. So charge is produced, electrification, the first process, when I produce charge by friction. So in friction we have studied, consider two bodies, put them in contact, move relatively. Friction, due to friction, electrons migrate from one body to another body. One body gets positive charge, other body gets negative charge. So in this process, let's suppose a glass rod, when rubbed to a silk cloth, right? A glass rod rubbed to a silk cloth is suspended by means of a string. So this gets positive charge. Now consider another glass rod rubbed to another silk cloth and again suspended near to this, like this. Let's say this glass rod gets positive charge. Now when I get these two close, they move apart. They are separated. Force of separation, right? Pushing force of separation, pushing apart. Now this they named it as force of repulsion. Later, similarly, suppose in second one, instead of glass rod, the first one is glass rubbed with silk suspended by a string. Instead of glass rod, if I get a ebonite rod rubbed with woolen cloth, right? When I suspend the ebonite rod, right, this negative, when I bring it closer to it, both get stuck up, they attract, come closer, approaching force, they approach, they come closer, attraction, clinch. So thus people noticed the two type of electrostatic forces. One is force of separation, other one is force of attraction. First one, glass rod and glass rod, two similar bodies. You know, when I rub a glass rod with a silk cloth, whatever nature of charge that it gets, in another glass rod rubbed with silk must get the same nature of charge. So two similar charges, when two similar charges were brought together, they move apart, separate, force of separation, pushing force moving apart, force of repulsion. So similar charges separate, repel, like charges repel, similar separate, like repel. So similar charges are separating one another, so like charges repel. Now when I get an ebonite rod gets an different charge. So glass rod and ebonite rod, this is glass and this is ebonite rod, and this two get attracted, move towards, come closer, approach, force of approach, electrostatic clinch. This is called force of attraction. So people noticed there are two types of electrostatic forces: force of separation and force of approach, force of repulsion and force of attraction. Now people thought, intuited, when there are two types of forces existing, then there must exist two different types of charges. Thus people came to a conclusion that there are two types of charges, different nature, named as positive and negative, right? So that way force has led to the separation of two charges like this. So first, forces, electrostatic force are of two types. Unlike mass, all mass is of same nature. There is only one type of force, a gravitational clinch. It's gravitational force of attraction as stated by Newton. But electrostatic force are of two types, force of attraction and force of repulsion. So in first case, when I was charging by conduction, when charged by friction, now two bodies when charged by friction put together and moved relatively, one gets positive, one gets negative. Now these two attract one another. So charging by friction leads to attraction. Charging by friction precedes attraction. A simple example, when you rub your hand to the handle of a chair, plastic chair, you rub a hand to the handle of plastic chair, then you notice the hair getting attracted towards. Rubbing the hand, friction, charge is produced. Now the hair gets attracted towards the chair. So charging by friction precedes attraction. There is attraction. Unlike charges are produced, so they attract one another. Like charges repel, unlike charges attract. Similar charges separate, get separated. Opposite charges attract. Unlike attract, similar separate. So you please remember such. This is a simple memory tip by which you can remember, right? Similar separate and unlike attract, opposite attract. Similarly, I have given the same thing in the previous video also. A small tip to memorize which body gets what type of charge. You have to remember such type of tricks you have to use so that you can remember this without confusion. You can write the things under any condition while writing the entrance there. You get confidence. So first case, charged by friction. Whenever charged by friction, then after being charged by friction, they attract. So charging by friction precedes attraction, right? First case. Second, when I charge by conduction, when bodies are charged by conduction. So I was telling you in the previous video, consider a already existing charged body and this is connected to another conductor, right? This charge is shared. You know, in charging by conduction process, similar charge is being transferred, shared. The same charge, a positively charged body, now when in contact with another conductor, same positive charge is shared. So when you consider charging by conduction, right, already existing positive charge, another one, when you put in contact, same nature of charge is being transferred, right? Now there are like charges, there after conduction they repel. So charging by conduction leads to repulsion, or charging by condition precedes repulsive force, repulsion. Charging by conduction precedes repulsion. For this, I'll give a simple example. Suppose, unfortunately, if any person gets in contact with an electric plug, whatever it is, right? Please don't try it, but at home. But unfortunately, let's say a person gets in contact with a plug there. So when you get in touch with it, in contact, a similar charge is given to you. Now, after getting charge, you are thrown away, you are repelled away, right? So when like charge, when you get in contact, then similar charge is given, then you are pushed away, separated charges, similar charges get separated, separate repulsion. So whenever you charge by conduction, similar charge is given, and this similar charge after being charged, they get separated. So conduction precedes repulsion. Third one, suppose when I charge a body, when a body is charged by induction, when you charge a body by induction, induction, affecting something without contact, right? So I was explaining in the previous video, when a charged body put in very close, nearer to a body, then unlike charge is deposited to the nearer end and the like charge to the other end. Now these two opposite charges deposit to the near end, these two unlike charges, this leads to attraction. Induction, so whenever charge is induced, opposite charge is being induced. When opposite charge is induced, now this leads to attraction. So induction leads to attraction, or induction precedes attraction. Opposite charge is induced, unlike charge. So unlike charge, attract. Opposite, attract. So when opposite charge is induced, there is attraction. For this simple example, when you move very close to a TV screen, a switched on TV, when you switch on the TV and when you move very close to the TV screen, that TV screen behaves as a plain charged sheet. So when you go close, just very near to it, then your hair gets attracted towards it. You being induced by the charge, the TV screen behaves as a plain charged sheet. Now that induces charge on you, your hair gets pulled, attracted. So charging by induction leads to attraction, or induction precedes attraction. But one point you have to understand. So if by three methods, whenever you give charge, so charge is being given to a body, then after being charged, either the bodies are attracted or repelled. Now this two types of forces. For this, the analytical approach of this force is given by Mr. Coulomb, right? Charles Coulomb has given the analytical formula for the force between two charges. The force between two charges, if I consider two charges Q1 and Q2 separated by a distance r, then force directly proportional to Q1 Q2 by r square. But before going to it, Coulomb's law is applied under certain conditions. Coulomb's law is not applicable to all types of charges. Let's say whenever you charge a body by induction, now when you induce, when charge is induced, the induced charge is spread over the body. Now their Coulomb force you cannot calculate. Coulomb force is applicable only for point-sized bodies. Point-sized bodies, point charges. What do you mean point charge? The size of the charged body when compared to the distance of separation. The size of the charged body when the size, radius of the charged body, distance of separation d, when r is very much less than d, then the charge can be considered to be a point charge. So point charge, for point charges only this law is applicable. Now what happens if it is not a point charge? If it is a big charge conducting sphere, then how do you apply? So luckily, whenever a big charged sphere is considered. A big charge sphere, when charge is uniformly distributed for a conducting sphere, then the center of all the charge lies at the center of the charged sphere. The center of the charge coincides with the center of the sphere. So you can assume all the charge is concentrated here. This is called center of charge. Similar as center of mass. So when charge, all the charge that is lying on the surface, all can be imagined to exist at the center. Similarly, another charge conducting, big conducting sphere where the charge is uniformly spread over the surface, you can imagine all the charge is being concentrated at the center. Now imagining all this as point charge and all this as point charge, now these two behave as point charges. Now the distance between their centers, you have to consider the distance between the charges, distance between the centers, right? So the line joining the center. The distance dr, it is the distance between the point where the charge is concentrated and this point where the charge is concentrated. So distance between the centers, right? This is the reason the force is inversely, force between 2 point charges. When I consider charge, all the charge is said to be concentrated at the center of charge. Even for this also, distance between them is r. Then the force F is directly proportional to, so force proportional to the product of the charges, and it is inversely proportional to square of the distance between the charges there. Now if I remove the proportionality, F is equal to small k naught q1 q2 by r square. So this is Coulomb's force. Now this constant is called Coulomb's constant, k naught. K naught depends on this k naught, small k naught. It depends on the system of units you consider, the system of units of all the quantities what you consider, and it also depends on the medium that is the medium that is present between the charges. It depends on the system of units what you consider and the medium that is present between the charges. Based on this, the constant k naught is defined. In various systems, force is defined as F is, in various system of units, force differs. CJ system, K naught is 1. In SI system, K naught is given as 1 by 4 pi epsilon. In SI system, K naught is given as 1 by 4 pi epsilon. Now epsilon is defined as epsilon. It is the constant, it is the constant of a medium which defines the extent to which it affects the force between the charges. It is the factor, parameter which defines the extent to which it affects the force between the charges there. Epsilon, permittivity of the medium. And so 1 by 4 pi epsilon, k naught is equal. So when I substitute, so force F is equal to 1 by 4 pi epsilon q1 q2 by r square. Okay.